and what we're supposed to do is figure out how much comes through this thing every second. Well, so if you stop and think about it, in 1 second, this chunk of water is going to come zooming out the pipe, and it looks like it's going 5 meters per second. So a thing to imagine is this little cylinder, long, skinny cylinder of water, and this is going to come shooting out of there. And what it's wanting us to do is figure out the volume that comes through this thing in a second. Well, so if you imagine a little cylinder like this, let's just call the area of the end of this thing A, and then if you remember the volume, to get the volume of a cylinder, that's just the area times like the height of the cylinder. So you could think of it like AH. Right, so if you want to, so the volume of this thing, if you go to part A here, it says find the volume that goes through each second. Well, so in general, the volume of that cylinder is going to be AH. And so, well, let's just figure out what that volume is. So the area is pi r squared. So the area of a circle is pi r squared, and then that height we're calling h. And so now we can start putting some numbers in. So you get pi. The radius is 0.012 meters. I'm not going to put the unit because I know I'm working in meters. And then we need to square it. And then the height that we want to use, well, it says each second. So what we really want to do is the distance we want to use is the full 5 meters, because the speed's 5 meters per second. So you're going to have 5 here. And then we just need to multiply this out. And so, right, if that's in meters squared and that's in meters, we'll get cubic meters. So we're going to do pi 3.1415, it's close enough, times 0.012 squared, and then times 5. And so what I get is, it says 0.0226 cubic meters, or 0.00226. So I'm going to put 2.26 times 10 to minus 3 meters cubed. Now that's a small number, but right, you want to think about the unit you're using here. A cubic meter that's a lot of water. I don't want to be around a hose where a full cubic meter comes out every second. So get used to that. If you're working in cubic meters, it's going to be a small number. Okay. Now, a more general thing though to notice about this is notice how we said the volume of this thing is area times height, but that was the volume in 1 second. Okay. Well, so something to notice about this is really what we did was we multiplied the area by, well, the height we took to be 5, which is really the velocity. So something I want to show you is that if you want to, so this is the volume is this area times height. The volume per time would be like area times height per time, this distance per time. So I could think of it like this, like vol per time equals, well, that would be area times height per time. But this like height per time or distance per time, that's the velocity. So equals area times velocity. So a very useful relationship with water flowing through tubes is that your volume per time that flows through it equals the area times the velocity. The area of the pipe times the velocity that the water goes through the pipe, or the fluid goes through the pipe. This relationship here is going to end up being by far the most useful and important thing that we do when we're handling like fluid flow. And then just as an easy check for like, kind of idiot check, see how the units are working out. Notice area would be like meter squared, and velocity, of course, is meter per second. And so notice you get from that meter cubed per second. So you can see that works really well. So super, super useful. So back to this just kind of original problem. It says find the volume of water. So we got this little small number of meters cubed. Now just to reality check it, I had us compare that or find the mass of the water, because that'll help you picture this a little better, because this is supposed to be like a real garden hose. And so for part B, what we need to do is, well, we got to find the connection between volume and mass. Well, so right now we have 2.26 times 10 to minus 3 meters cubed. But then what we want to do is get to kilograms from cubic meters. Well, we know that every 1 cubic meter and I know I want to put that downstairs because I want to cancel cubic meters, weighs 1,000 kilograms, or its mass is 1,000 kilograms. So we have 2.26 10 to the minus 3, but then we multiply by 10 to the third, and so you actually get 2.26 kilograms of water coming out every second, which is pretty reasonable for like a garden hose. It's kind of like a full blast garden hose. So you get a good chunk of water coming out of there. So despite the fact that this looks like a small number, it's actually a decent amount of water because cubic meter is just absolutely huge. So that's how you figure out how much water comes out. Take home point here, by far, the most important thing is this notion of the volume per time being area times velocity.